Hello, everyone, and welcome back to your Daily English Dose, your channel for boosting your English skills through engaging real-world stories. Today, we're diving deep into something pretty major, an event that really shook the digital world. The massive AWS, that's Amazon Web Services outage, back in October 2025.
Yeah, it wasn't just, things slowing down a bit.
Not at all. This was like a complete digital blackout. It brought huge parts of the global internet to a grinding halt.
It really was a shocking moment for, well, pretty much everyone using technology.
Yeah.
Millions felt this sudden digital silence, and it really exposed some serious vulnerabilities in how we've built our online world.
So our mission today is kind of twofold.
Exactly. First, we want to break down what actually happened, step by step. And second, we want to help you, our listeners, understand and maybe use some key English vocabulary related to tech and global events that really came to the forefront during this crisis.
The impact was just so immediate and so personal for many. I mean, think about it. Maybe your smart speaker, your Alexa, just stopped responding.
Or your Ring doorbell didn't send you that notification. Big online games like Fortnite, Roblox players were just stuck, couldn't log in. Millions of people suddenly cut off from their entertainment.
Yeah, total paralysis there.
And it went way beyond just fun and games. Essential financial services, think about popular apps like Venmo or Coinbase. They just stopped working. Poof.
Wow. Transactions just halted.
Completely stopped.
Yeah.
Across continents.
Hmm.
It was a stark reminder that our modern society really leans on this digital foundation that frankly turned out to be surprisingly fragile.
Okay, let's get into the timeline then. The day the internet seemed to pause.
Right. And the scary part was this wasn't just like a local problem in one city.
Yeah.
Outage tracking sites, down detector is a big one. They were just flooded. Millions of reports pouring in from the US, the UK, Australia, Japan, all at the same time.
So for the average person, it must have felt like a huge chunk of the internet just vanished.
That's exactly how it felt for many people, yeah. A large part of the internet was simply down.
So looking at the timeline, it wasn't like flicking a switch off instantly, was it? It sounds more like a chain reaction.
It was. The very first objective signs, the data, started appearing around 07.55 UTC. That's when internet monitoring services, Thousand Eyes is one example, they noticed service availability starting to dip.
And specifically in that U.S. East 1 region, the one in Northern Virginia.
Precisely.
Yeah.
The critical U.S. East 1.
Yeah.
Then it took AWS themselves a little bit to, officially say something.
Okay, when was that?
At 08.11 UTC, they updated their official status page. They said they were, and I quote, investigating increased error rates and latencies in that specific region.
Okay, you mentioned latency there. That's a technical term. For our listeners, maybe building their vocabulary, what's a simple way to think about latency?
Oh, good question. Yeah, latency is super important in networking. Basically, it just means delays. Delays in getting data from point A to point B over the network.
So high latency means things feel slow.
Exactly. Really high latency. And things essentially just stop working altogether. It's like the data takes too long to arrive.
Got it. So increased error rates and high latency. Things were grinding to a halt. And they eventually found the cause.
They did. It took a couple more hours. At 10.01 UTC, AWS announced they'd identified the root cause.
Yeah.
It was related to DNS resolution for DynamoDB API endpoints.
Sounds technical,
Yeah.
I know.
I'll break that down.
Yeah.
But the fix wasn't quick, right? You mentioned this recovery took ages.
Agonizingly slow. Over 12 hours of significant impact. See, even after they tried to put fixes in place, the term we use is mitigation, the whole system stayed really unstable.
Right, mitigation. So that's like the actions you take to try and lessen the damage or fix the problem.
Exactly, trying to reduce the severity. But it was like playing whack-a-mole. They'd fix one thing, another would pop up. And a huge part of the problem was this massive backlog.
Backlog.
Yeah, a huge queue of all the requests that hadn't been processed while things were down. So even as they tried to bring systems back online, this giant wave of old requests just slammed into them, overwhelming everything again. It took a very long time to clear out that backlog. Okay, so that explains the slow recovery. Let's get to the core of it, the technical weak spot. Why U.S. East 1? Why did one region failing cause such global chaos? What's the deal with this Achilles heel?
Right. Well, US East 1 is special. It's the oldest AWS region. It was the first. So naturally, it has a concentration of older systems, legacy architectures, you could say.
But the really critical part is that it hosts the control plane for a lot of global AWS services, isn't it?
That's the key vulnerability. The control plane. Think of it like the central command center. the global headquarters for AWS operations.
The nervous system.
Yeah, or the brain. It manages really crucial background functions, especially things like user authentication, logging people in, and managing core services. The big one is IAM, Identity and Access Management.
Wait, hang on. So you're saying even if my company runs its entire application, let's say purely in the Tokyo region, it still depends on that US East 1 control plane for basic things like letting my users log in.
That's the hidden dependency that got so many people out.
Yes. Core management often rests back to US East 1. Wow.
So when that control plane in Virginia goes down, the potential damage engineers call this the blast radius. It's not just local, it's global.
Okay, let's quickly define those for our listeners again. Control plane, that's the brain, the command center managing the system.
Right.
And blast radius, that's the potential area or scope of damage if that brain fails.
You got it. That makes sense.
It does. Okay, so the immediate trigger you said was a DNS failure affecting DynamoDB.
Correct. Let's break that down. DNS, the domain name system, it's basically the internet's phone book.
Right. It translates names we use, like a website address, into the numerical IP addresses computers understand.
Precisely. And DynamoDB. Think of that as a giant, super organized digital filing cabinet. It's a core database service used by thousands, literally thousands of popular apps.
Like storing user profiles for Snapchat or maybe game data for Fortnite?
Exactly, that kind of stuff. Crucial application data. So the problem was the internet's phone book, DNS, temporarily lost the phone number, IP address, for that main filing cabinet, DynamoDB, located in US East 1.
So apps suddenly couldn't find the data they needed. It was like temporary digital amnesia.
That's a great way to put it. Temporary amnesia across thousands of services.
But you also mentioned this DNS failure was just a symptom, not the absolute root cause.
Correct. The deeper dive, the postmortem analysis from AWS, pointed to an issue in an internal system that manages traffic flow. Specifically, they said an internal subsystem monitoring the health of network load balancers.
Okay.
Basically, a component whose job is to manage network traffic and check if things are healthy.
Yeah.
It failed first. That failure then caused the DNS system to break,
Mm-hmm.
and that took out DynamoDB. And then, well, the dominoes really started falling.
Ah, the domino effect. That leads us perfectly into the next part, how this initial failure cascaded. You use the term cascading failure.
Yes, a cascading failure. It sounds dramatic because, well, it is.
How would you define that simply, like for our listeners?
Think of a line of actual dominoes. You push the first one, and knocks down the next, which knocks down the next, and so on. A cascading failure in a system is just like that. One part failing triggers the failure of the next part that depends on it. Then the next, then the next.
That chain reaction.
Exactly. It was almost inevitable here because of how interconnected everything is. DynamoDB went down.
And then everything that relies on DynamoDB started failing too. You mentioned things like Lambda functions.
Yep, Lambda functions, those little bits of code that run automatically. And the API gateway, which manages how different software components talk to each other, they rely heavily on DynamoDB, so they failed immediately.
But it gets worse, right? Because the systems designed to fix problems also got hit.
That was the really insidious part. The main monitoring service called CloudWatch, it was impacted by the outage too.
Oh, no.
Yeah. And CloudWatch provides the data for auto-scaling the system that's supposed to automatically add more servers, EC2 instances, when things get busy or start failing.
So without the monitoring data from CloudWatch,
Auto-scaling was flying blind. It couldn't see the problem, so it couldn't react. The system lost its ability to automatically heal itself or increase capacity.
wow. So the system is failing and the automatic doctor is basically unconscious.
Pretty much. And that led to this horrifying situation people called the Retry Storm.
Retry Storm. What's that?
Think about it. Millions of apps and web browsers worldwide are designed to automatically retry connecting if a service fails.
Okay, yeah, that makes sense. You hit refresh or the app tries again in the background.
Exactly. But when thousands, maybe millions of clients all start retrying their failed requests to DynamoDB and other affected services at the same time,
Oh boy.
it creates this overwhelming flood of traffic, this digital panic. That's the Retry Storm, and it hit the AWS systems right as they were trying to recover.
So it's like trying to stand up while a huge wave crashes over you.
Perfect analogy.
Hmm.
It generated that massive backlog we talked about earlier and just completely overwhelmed the infrastructure, making the recovery process much, much slower and harder.
Yeah.
It really showed how system complexity doesn't just cause failures, it can actively prevent recovery too.
Incredible. So let's talk about the fallout, the real world impact. It was massive.
It was stunning. We saw it hit finance hard.
Yeah.
Coinbase, Robinhood, popular payment apps like Venmo, They had major issues. Trading halts, payments failing.
And it wasn't just U.S. tech startups,
Yeah.
right? Even big established banks.
Yeah, reports came out that even major UK banks like Lloyds and Halifax experienced disruptions. It showed how deeply integrated everyone is.
Wow. And then entertainment.
Oh yeah, Netflix, Disney Plus streaming issues. The PlayStation Network had problems. Even educational apps like Duolingo or simple games like Wordle were affected.
And logistics, too, even physical delivery.
Yep, Delta Airlines reported disruptions, and maybe ironically, even Amazon's own delivery warehouses and logistics systems were impacted by the AWS outage.
That really underscores the dependency. And for our listeners, especially maybe those in Asia, the impact was felt there too, right? It wasn't just a US-Europe thing.
Absolutely. A very clear example was the Nintendo Switch online services. Lots of players couldn't connect. And many smartphone apps popular in Japan and other parts of Asia also reported problems.
How did that happen if the core issue was in the US East?
Often through content delivery networks like AWS's CloudFront or other hidden dependencies, routing back to that US East 1 control plane we discussed. The surge in outage reports from places like Tokyo and Osaka proved it wasn't isolated.
This whole thing really brought up something experts call the asymmetry of pain. Can you explain that?
Yeah, it's a critical point. Think about it. Thousands of businesses worldwide, AWS customers, suffered huge economic losses.
Yeah.
Lost sales, lost productivity, potentially billions of dollars collectively.
Okay.
But for Amazon itself, their stock price barely moved, and their actual financial liability, what they might have to pay back to customers, is usually limited by their SLA, the service level agreement.
Ah, the SLA. That's the contract between the provider and the customer about service quality, uptime guarantees, that kind of thing.
Exactly. But the credits or refunds offered under an SLA are typically tiny compared to the actual business losses customers suffered.
So that's the asymmetry. The customers feel immense pain, but the cloud provider, Amazon in this case, is relatively insulated from the financial consequences of the outage.
Precisely. And it raises tough questions, about the incentives for these giant providers to invest potentially billions more in preventing such outages if the direct financial hit to them isn't proportional to the damage caused downstream.
That leads right into the big lesson, doesn't it? Concentration risk.
Absolutely. The global digital economy has become incredibly reliant on just a few huge cloud providers, AWS, Microsoft Azure, Google Cloud, the big three.
And this outage showed the danger of that concentration.
It did, because that US East 1 control plane essentially became a massive single point of failure, or SPOF, for huge swaths of the internet.
Okay, SPOF, single point of failure. That means if that one specific part breaks.
The whole system, or a very large part of it, stops working.
Yeah, that's a critical concept. And given the scale, I remember hearing the UK Parliament actually started asking questions like, why wasn't Amazon designated a critical third-party provider, considering the potential systemic risks?
That's right. It triggered national security level concerns about this dependency.
And the outage also showed that maybe the old ways of building in backups weren't enough. Talk about redundancy.
Yeah, this was a wake-up call. Many companies thought they were safe because they used what's called a multi-AZ architecture. AZ stands for availability zone.
Which means spreading your system across multiple separate data centers within the same geographic region, like US East 1.
Exactly. It protects you if one single data center building has a fire or power cut.
But this failure was higher up. It was at the regional control plane level, affecting all the availability zones in US East 1.
Precisely. So multi-AZ redundancy offered no protection in this specific scenario. It failed.
So what's the answer then? If multi-AZ isn't enough?
The new focus is on true resilience. Resilience meaning the ability of a system to actually withstand and recover quickly from major disruptions like this.
Okay, resilience. How do you achieve that?
It generally means moving beyond just one region, designing for multi-region architectures. That means being able to actively fail over, basically, switch your operations smoothly to a completely different geographic region, maybe US West 1 or Europe or Asia if US East 1 goes down.
Or even multi-cloud, using more than one provider.
That's another strategy some are exploring, though it adds complexity. The core idea is you have to design for failure, assume these things will happen, not just hope they won't.
That makes sense. Assume failure. And there was one more factor mentioned, sort of a non-technical one. The human element.
Yeah, it's something analysts have been discussing. Some experts suggest there might be a link between the increasing frequency or severity of some major outages recently and what's sometimes called a brain drain at some big tech companies.
Meaning experienced engineers leaving.
Potentially, yeah. The idea is that maybe some of the deeply experienced engineers who really understood the intricacies of these older complex core systems might have moved on, leaving fewer people with that critical institutional knowledge needed to manage them perfectly or recover quickly when things go wrong.
That's a fascinating and slightly worrying angle to consider.
It is. But the main takeaway, the big lesson from this 2025 outage, is crystal clear. The cloud isn't magic. It's not invincible. It's not infallible.
It's just someone else's computer.
That's the classic phrase, yeah. There is no cloud. It's just someone else's computer. And companies, developers, everyone building on it absolutely must design their systems, assuming parts of that computer infrastructure will inevitably fail.
So as everyone listening reflects on this, maybe think about this. How many apps on your phone stopped working that day back in October 2025? This event really proved our digital lives are maybe more centralized and frankly more brittle than many of us realized. The big challenge going forward is how we build a more decentralized, more robust, more resilient digital world.
Well said.
Okay, we covered a lot of ground and a lot of really useful English vocabulary today. Let's quickly recap those key terms for practice. We had outage, latency, mitigation,
Control plane, blast radius, cascading failure.
then asymmetry, SLA, service level agreement, concentration risk, SPOF, single point failure.
Yeah.
And finally, redundancy and resilience. Quite a list.
Definitely some great words to add to your vocabulary. Thank you so much for joining us on your daily English dose. If you found this breakdown insightful and hopefully helpful for your English practice, please do hit that like button.
Yeah, let us know.
Share your thoughts or maybe your own experiences from that day in the comments below. And tell us if there are other big tech or global events you'd like us to break down like this for English learning.
We'd love to hear your ideas.
Don't forget to subscribe and click that notification bell so you don't miss our next dose of English learning exploration. Until next time, keep practicing, stay informed, and keep learning. Bye for now.
Bye, everyone.